What we have here today is a 2016 Ford Fusion. What we're going to attempt to do is an oxygen storage capacity test. The newer the vehicle is, the more likelihood that the onboard computer will be utilizing oxygen storage capacity for its catalyst efficiency test. Obviously, the opportune time to do this would be in the service bay, so a lot of technicians will use what's called propane enrichment. The concept is to add propane, both oxygen sensors, the upstream oxygen sensor and the downstream oxygen sensor will indicate a rich mixture. At that point in time, when we have pretty much a rich mixture showing on both oxygen sensors, we'll shut off the propane, maybe make a vacuum leak or remove the propane that may be interjected between the mass air and the throttle body, and that'll bring in some fresh air, so we'll basically go into a lean condition. Then we're going to immediately see the upstream oxygen sensor lean out, and then we should see over a certain amount of time the rear oxygen sensor follow. The time is very important. From the time we shut off the propane, lean the mixture, we want to count how many seconds before the rear oxygen sensor follows. That will tell us the oxygen storage capacity. We really need to see an oxygen storage capacity go over 3 seconds. What we're going to do now is set up the scan tool, the Verus, and set up what we want to look at in graphing mode. So I'm going to go ahead and pull up the lambda equivalency ratio for bank 1, sensor 1. And I want to pull up the rear oxygen sensor. Which is bank 1, sensor 2. And then we'll go into graph view. So in our graph view on the left-hand side, we have the downstream oxygen sensor, which is a narrowband, bank 1, sensor 2. And on the right-hand side, we have the lambda equivalency ratio, which is our wideband oxygen sensor on bank 1, sensor 1. Now remember, with the equivalency ratio, the higher the number, the leaner. As the number goes lower, then the mixture is richening. Now we're going to get set up to introduce our propane into the engine. Remember that you don't want to introduce the propane in front of the mass airflow sensor. You don't want to run the propane over the hot film or hot wire mass airflow sensor. So we're going to introduce the propane between the mass airflow sensor and the throttle body. Okay, the equivalency ratio is floating around 14.7 to 1, which is around a 1 equivalency ratio. The downstream oxygen sensor is floating around 700 millivolts. So let's go ahead and introduce the propane. You can hear the engine change from the rich mixture, and immediately you see the equivalency ratio drop. Still adding propane. I'm going to go ahead and pause this. As you can see, when I added the propane, initially the equivalency ratio dropped, indicating a rich mixture. But in less than a second, it recovered. I did not shut off the propane. This is showing us how fast modern vehicles' computers are in adapting to changes in the mixture. This is the latest and greatest technology on this 2016 Ford Fusion. We have a wideband oxygen sensor. We have a very fast Bosch computer. As soon as it's seen the rich mixture, it would use all of its resources, short-term fuel trim, long-term fuel trim, and defeat the additional fuel, pretty much making it impossible for us to do an oxygen storage capacity test in the service bay. Now, there are options that will work. So let's say the vehicle we have in the shop has a catalyst efficiency code. The first question is, Does the onboard computer utilize index switch ratio or oxygen storage capacity? What you want to do is you want to look at the enabling conditions in your research, and when you read about it, you'll get the gist of whether or not it uses index switch ratio or oxygen storage capacity. Let's say we want to run the oxygen storage capacity test. Well, I've come up with a solution. Notice that the red line is the upstream oxygen sensor that is dancing. The converter is already hot, as you can tell by the flat line, or pretty much flat, blue line. What you do is make sure everything's warmed up, it's hot. You don't have to be in third or fourth gear running over 100 miles an hour, but you want to be in low gear, and you have to find a place where you can safely accelerate to wide open throttle. When you do that, you will enter power enrichment mode. In power enrichment mode, your upstream oxygen sensor, your downstream or upstream air-fuel ratio, they're going to indicate a rich mixture. Once you see that you went rich, go ahead and remove your foot from the pedal. From that point, immediately you're going to enter decel fuel enleanment or decel fuel cutoff. As you can see, immediately the red line drops off because we went from power enrichment mixture to decel enleanment. The front oxygen sensor dropped, but look how quick the blue line, the rear oxygen sensor, followed. This is a failure.